Hey everyone. So for our first chapter 11 video on section 11.1, we're going to talk about two important ideas called measures of center and measures of variation. First, at the top of this page here, we just have kind of summaries of some data displays. Some of these data displays you've seen before, some maybe you haven't. I'm not going to go into too much detail here but just a little overview. We have a histogram which shows a count of how many data points fall into each we call these bins or widths. So like how many data points fall into 6 to 10, about 30. Dot plots, you've probably seen that before. A couple examples there. Box and whisker plot, we're going to learn a little bit more about this next week. Histograms are coming the week after that. And the other type here, and we're going to see this a little bit more this week, is called a stem and leaf plot. This one can look a little confusing at first, but it's actually not too bad. I'm going to zoom in on it. We've got one here, phone battery comparison. And so the stem is like the beginning of a number, and the leaves in this stem and leaf plot are like the rest of the number. And so you can even see at the bottom here, there's this key. It sort of explains it. The 6 line 1 stands for 61 hours. All right, well, that comes from looking at these stem and leaves. So if I start with the first stem, it's 0. And using that stem, if I go to the right here, so my first data point here is just going to be 0, 7. We don't usually write the 0 though, so it's just 7. And then again, we'll go to the right here. 1, 0, that would be 10. And then 1, 5 would be 15. 15, there's 3 15s. And then 17 and 19. We could also go to the left. And so if I looked at the data on the left here, starting with the 0, I would have the data points 5, 7, 8, and 8, because those all just have the 0 in front. And then this is like 10. And so 10 and 11 and 14 and 17 and 19. So that's how a stem and leaf plot works. So like again, if I looked here, that 7 represents 70, and so my data point is 75. So it's a good way to display a lot of data. All right, so this next part here, we're going to look at some definitions. And I've already got it filled in. So my recommendation is let's pause it, copy some things down, and then I'm going to talk through it a little bit to just make sure we have a good understanding of it. A lot of this you've seen before, so I'm not going to spend a lot of time on it. Okay, so we've got these 3 words here, mean, median, mode. All right, mean, you've heard of it. It's like the average. Add up all the numbers and divide by n. N is how many numbers you had. So if you had 6 numbers, you add all those 6 numbers up, divide by 6. Okay, a symbol we might see a little bit of is called X bar. It's literally an X with a bar on top. It means the mean. You ever see that? That's what it's talking about, is the mean. When do we use the mean? It's really describing the typical value well if there aren't outliers. Okay, and so this is a good time to really kind of talk about a measure of center is really meant to be a typical, quote unquote, typical data point. And so context you've seen this a lot is like your test scores. If I say the average score on the test was 88, I kind of mean the typical test score was 88, right? That's sort of how you think of a mean, right? It describes the mean well, or describes the typical value well, if there aren't outliers, all right? But what we're going to see is that outliers really kind of mess with the mean. And an example that would be like if there were 2 people who got like 30% on the test and everyone else got in the 90s, that's going to bring the mean down, right? And so the typical score might be 80 for that, even though most people actually got 90s, but those 2 outliers that are a lot lower kind of brought the average down. So that's why a mean would not be a good use of the typical a description of a typical data value if there are outliers. So that's where the median comes in. The median, it's the middle number in a data set. And I think you've seen this before. You put all the data in order, and then the middle number is the median. If there are two middle values, then you would use the average of those two. The median splits the data in half, so 50% of the data is above and 50% is below. So it's a really good description of the typical value that's better than the mean when there are outliers. Because the outliers don't affect the median as much because it still splits the data in half 50-50. 50 below the median and 50% above the median. The mode is our third type. It's the most repeated number in a data set. When do we use it? Kind of when it's interesting. And if there are two modes that aren't close to each other, that's a situation where it's kind of interesting. But we don't usually use it to describe the typical data point. What measure of center is the best? It depends. We need to look at the entire picture of the data, and that's what we're going to start practicing in this unit. So we also have to talk about measures of spread. So that's what we're going to do next. So measures of spread, or more formally, measures of variation. Like if you think about variation, how much does something vary? It just means is how different from typical is most of the data. Okay. Another just way of thinking is like how spread out is the data? Is it all really close together? Like everybody on the test got an 89, a 90, or a 91. All 30 students. That would be really not spread out at all. So it would not have a lot of variation. But let's say we had 4 people in the 50%, and 6 people in the 60%, and 6 people in the 70%, and 7 people in the 80%, and 6 people in the 90%. That's very spread out. That would be data that has a lot of variation. Okay, so we have two measures of variation, range and standard deviation. Range is easy. You've heard of it before. It's the width of the data from smallest to biggest value. And how do you find it? You take the maximum and you subtract the minimum. Max minus min. Standard deviation, okay, kind of a fancy sounding word, or two words, and it's a measurement of how spread out the data is. And it's kind of a big calculation. It's a formula. We're not going to even look at the formula. If you take a statistics class, you'll learn about the formula. But it's a kind of a measurement of the typical distance from the mean. Okay. Sometimes you'll see this sigma notation. It's a lowercase Greek letter, sigma, and that's a symbol that means standard deviation. Other times, and this is what we'll see on Desmos in a few minutes here, is you'll see it abbreviated as STDEV, standard deviation. We're going to find it on the calculator or on Desmos, as we'll see in a second. Again, it's a typical distance from the mean. All right, if I were to pick any random data point, about how far away from the mean would I expect it to be? Okay. A couple other thoughts here before we talk about Desmos. If we have a small standard deviation, that means the data is clustered together. So when I gave that example of all the tests being 88, 89, or 90, whatever number as I used, that would be a small standard deviation, but the ones that were very spread out from all the 50s all the way into the 90s, that would be a large standard deviation because the data is more spread out. So an outlier is a data point that seems out of place because it is much lower or higher than the rest. And that's a phrase I think you've heard before as well. But the question that's more interesting for us right now is what measures of center does it and variation does it affect? an outlier has a big effect on the mean, and that's again what we kind of talked about. Is if everybody scored in the 90s, the average would be in the 90s. But then if you had one person who had a 60 on a test, that would bring the mean down, right? And so maybe the mean would be in the 80s, even though everyone else except that one outlier was in the 90s. But it has very little or almost often no effect on the median because it's only one data point, so the 50-50 split stays about the same. It is going to affect the standard deviation in the range because if it makes the data more spread out. All right, for the rest of the video here, we're going to quickly move on to Desmos to explore how do we find mean, median, mode using the online graphing calculator in Desmos. So as you can see, I've pulled up Desmos here. I think if you could do that as well on another tab, that'd be great. You get to, after you click the Start Graphing button, what we're going to do here is basically create a table on Desmos. All right, and so to do that here, you're going to click that little plus button and add a table. And then we're going to enter all our data into just one of the columns. So it doesn't matter, we can use X1. If you want to rename it, you can. I'm not going to. I'm just going to leave it as X1, but you can rename it. Right, and so then we're going to type in all the data. So I'm going to take a second, pause it, and I'm going to type in all of this data here in this X1 column. Once you have all the data in, what we're going to do here, and you can see it's all there in X1, is there's on this keypad here, there's a stats or functions and then stats menu. And I have to zoom out to show you this. So at the far right, you see the functions button, and you're going to click that, and then look for stats. Okay. Now what you want to do, and I didn't do this, is in your screen here, you want to get down to the next line in your kind of this entry calculator here. You want to get to the next line, and then in stats, you've got all these choices like mean, median, min, max. And so I'm going to click on mean, and we have to tell it what do we want to take the mean of, and that was X1 was the name of our column, so X1. You type it in, and look at that, the mean just shows up for us, so we know the mean is 62. Okay, and then we can leave that there if we want. We can leave that there if we want, and click into the next box, and then go back into functions, stats, and we'll click on median. We go median X1, and we see the median is 60. Okay, mode is the one that shows up the most, and if you look in that functions menu, it's not one of our choices. So we have to actually calculate that ourselves here. So do any of these data points repeat? I see a couple of 60s, I see 3 60s, I see 4 60s. 60 is the mode because it shows up the most. Okay, range is another one that is not in the list here, but we can actually use Desmos to find the min and the max. And so if we want to find the range, we would do the maximum of X1. And it tells us right now that that's 73. So I might write that down, just a little side note here. But we can just use the calculator to actually do it for us. So we have the maximum, we have to just subtract the minimum. So now we go minus, and then you go back to function stats and find minimum, and then X1, and it actually does the math for us. The max minus the min is 24. So that's my range. If we did this by hand, that minimum would be the 49, and so that's where the calculator is getting 24 from. Finally, standard deviation, we can do that once again on here, functions, find STDEV, it is the kind of third one, third column, third row. Click on that, and we type in X1, we get 6.2289, We usually will round that to 1 decimal, so we're going to call it 6.2. Okay. What that means is for this data set, we've got the mean is 62, and coincidentally, this is a coincidence, so is the standard deviation is 6.2, which means a typical data point is about 6.2 away from the mean. All right. We have to practice more with that, but that's kind of just generally how you're going to use Desmos to do that. So that you'll do that in your homework, and thank you for watching. Hopefully this was helpful.